Probably one of the most common statistical analysis is comparing means to determine if a difference exists. For example, if we randomly select and place patients into two groups, where one group gets a standard treatment for a particular condition, while the other group gets an additional new treatment. Then, we measure the effects of the two different treatments on the dependent variable and run a statistical analysis to determine if enough of a difference exists between the two means to reject the null hypothesis. Let's go back and look at the null hypothesis which I suggested previously, that there is no difference in final grades between students completing a human anatomy course in lecture format only versus lecture with a cadaver lab. The independent variable is the cadaver lab. The dependent variable is final grades, which will be measured by the final score received by each student. We have two groups into which we have randomly assigned the students. The control group is the lecture-only group. Now, we look at the final grades of each group and then run a statistical analysis to determine if we should accept or reject the null hypothesis using a significance level, or p-value, of 0.05. Here are the final grades for the two groups. Notice that the lecture-only group has 12 students while the lecture with cadaver lab group has 13. This does not matter as we are not trying to match or pair the scores. The statistical analysis is going to use each score compared to the mean of its group to compare with the other group and determine whether to accept or reject the null hypothesis. First, I inputted the data into an Excel spreadsheet and calculated the mean and standard deviation for each group. Then, I stated the mean for each group and noted the mean as plus or minus 1 standard deviation. Note that in each case I rounded the number to 2 decimal places. As a review of the process to determine means and standard deviation in Excel, it would be good for you to enter the data and complete the mean and standard deviation calculations as I've shown on this slide. By just comparing the means and standard deviations between the two groups, it doesn't look like much of a difference, and that maybe the null hypothesis is correct. However, let's run a statistical analysis and make our decision based on the results. The statistical analysis we will use to determine if there is a significant difference between two means is the t-test. There are two different t-tests, one for independent or non-paired samples, and one for dependent or paired samples. The independent t-test is used to compare the means of two independent groups of subjects, as with our example of two groups of students, one group lecture only, and one group with a cadaver lab. The dependent t-test is used when the data are paired and subjects are being compared to themselves. For example, if we wanted to see if patients improved with a particular treatment by testing them before and after the treatment. We would therefore compare the pretest and post-test or paired scores, and the pretest scores would act as their control. In the example we are starting with, there are two separate groups with different subjects, and therefore we will be analyzing the means of the two groups to determine if we should accept or reject the null hypotheses using an independent or non-paired samples t-test. While viewing this presentation, it is recommended you use the pause option to work through this example. Pause the presentation now and open an instance of your web browser and go to this site. We will use this online resource in order to complete our t-test analysis. The first option you will have when scrolling down at this website is to decide the data entry format. The default is to enter up to 50 rows. For us, this will work fine and we will not change it. Then we need to choose a test. In our example, we will choose the unpaired t-test for independent groups or samples since we have two different groups of students in our study. Then we scroll down at the website and enter our data, placing the final grade scores for the lecture-only group in the Group 1 column and the final grade scores for the lecture with cadaver lab group in the Group 2 column. This website statistical analysis does not make a mistake. If there is a mistake in the calculation, it is because you entered the data wrong. Always check to make sure you entered the data correctly. Then choose Calculate Now on the website. The website always calculates a two-tailed p-value, which is what we prefer. The p-value that was calculated for our data in comparing the two means is 0.9206. As noted by the website analysis, the difference between the two means is not considered to be statistically significant since the p-value is above 0.05. Therefore, we accept the null hypothesis. Our study shows that the addition of a cadaver lab to the anatomy course did not significantly improve final grades. In the previous example, we compared two means in a study to determine if there was a statistically significant difference. These two means came from two independent or separate sample groups. In some studies, two different scores are obtained from each of the samples or subjects, such as the example on this slide, where pinch strength was measured before and after therapy intervention, a pre-test and a post-test. In this case, we need to analyze the results using a dependent or paired samples t-test. In reviewing the information referenced in your text, it is necessary that you understand this difference in choosing an independent samples t-test versus a dependent samples t-test before continuing. Before running the dependent or paired samples t-test, I used Excel again to determine the pre-test and post-test means and their standard deviations. Reset your internet browser by going back to the home screen for the t-test analysis. The data entry format will remain at the default of entering up to 50 rows. Under Choose a Test, however, we will want to change this to a paired or dependent t-test. Now, enter the data into the cells on the website, this time entering the pre-test in the Group 1 column and the post-test score in the Group 2 column. It is critical that the paired scores for each subject be matched between the two columns. Once we have the data entered, we select Calculate Now. The two-tailed p-value for this paired t-test is shown as less than 0.0001. It is also noted that this difference between the paired means is extremely statistically significant, and we would therefore reject the null hypothesis. Our study has shown a significant improvement in pinch strength due to therapy. This completes the presentation on t-tests to compare two means. Take time to go back over this presentation and practice as much as needed. Also, please be sure to review the information referenced in your text for this presentation. It will certainly help your understanding. When ready, move on to the next presentation, which will review how to statistically analyze more than two means.